Rules of rotation. All the points in a figure rotate together, including the vertices. All the points comprising the figure follow the same rule. So we can determine the effect on the figure by investigating the effect on a single point. That will then be the same for all the vertices and the lines connecting them. This course will be limited to rotations of 90 degrees, 180 degrees, and 270 degrees. We begin with those rotations about the origin, 0, 0, of the graph. Let's explore how the coordinates of points change after it being rotated counterclockwise about the origin by 90 degrees, 180, or 270 degrees. Let's begin with a 90-degree counterclockwise rotation of a single point. Draw the pre-image point A at point 2, 3. Right? You go over 2 and up 3. Draw a vector from the origin to point A with its x and y components. X, y components, and here's our vector. Rotate the vector and its components 90 degrees counterclockwise. That's going to be this angle right here. Rotating the components 90 degrees results in them each falling on the other axis. The original y component, over here, falls on the negative x-axis, right over here. The original x component falls on the positive y-axis up here. Observe that after a counterclockwise 90-degree rotation, x prime now equals negative y, and y prime equals x. So our original coordinates, x comma y, becomes negative y, x. So a, which was at 2, 3, becomes a prime at minus 3, 2. Keep in mind that x prime, y prime are the coordinates of the point after rotation, and x comma y are the coordinates before the rotation. Let's repeat that process for 180-degree counterclockwise rotation. Draw a vector from the origin to point A along with its x and y components, just like we did earlier. Then rotate the vector and its components 180 degrees counterclockwise. Rotating the components 180 degrees results in them each falling on the opposite side of the same axis. The original positive x component falls on the negative x-axis. The original positive y component falls on the negative y-axis. Pre-image A is located at 2, 3. Image A prime is located at minus 2, minus 3. After a 180-degree counterclockwise rotation, x prime becomes negative x, and y prime becomes negative y. So x comma y becomes negative x, negative y, and for this problem, 3, 2 becomes negative 3, negative 2. Exploring the effect of a 270-degree counterclockwise rotation, which is equivalent to a 90-degree clockwise rotation. Right? Because if you add those two up and get 360, you're good. So 270, you'd be rotating like this, but it's a little easier to see the 90-degree clockwise rotation there in purple. So rotating the components 270 degrees counterclockwise or 90 degrees clockwise results in them each falling on the other axis. The original y component falls on the positive x-axis. The original x component falls on the negative y-axis. Pre-image A is located at 2, 3, and image A prime is located at 3, negative 2. After a 270-degree counterclockwise rotation, or 90 degrees clockwise, x prime becomes y and y prime becomes negative x. So x comma y becomes y comma negative x, so 3, 2 becomes 3, negative 2. To summarize the rules revealed by our investigation for rotations around the origin in the counterclockwise direction, the coordinates of the image x, y are transformed as below. A 90-degree counterclockwise rotation transforms x comma y to negative yx. A 180 degree rotation transforms x comma y to negative x negative y, and a 270 degree counterclockwise rotation transforms xy to y negative x. This is true for all the points comprising the pre-image and image, so the pre-image and image are congruent. If the figures are congruent, determining the rotation for one vertex provides the rotation for the entire figure. Let's just take a look at these. Here, the x's and the y stay in the same position, they just change sign. Here, x and y switches to yx, and you have a negative y and a positive x. And here for this rotation, once again, y and x switch places, but this time y is positive and x is negative. That could help you remember these when we do problems. If a problem asks for the transformation of a clockwise rotation, then subtract the angle of the clockwise rotation from 360 degrees and use the counterclockwise transformation rule. So the blue is from the previous slide. So a 90 degree counterclockwise rotation gives you the same result as a 270 degree clockwise rotation. 180 doesn't matter which way you go. Counterclockwise, clockwise, you get the same result. And a 270 degree counterclockwise rotation is the same as a 90 degree clockwise rotation.